Okay. Alright, so here we have an H-like ion, which contains only one electron, has energies like in the hydrogen atom, but with a small modification. So and then a Z squared over N squared, where that is our atomic number. And that's our principal quantum number there. Okay. And Z's the atomic number. So it wants, the question is looking for the ionization energy for helium plus. So helium should have 2 electrons. Helium plus only has 1 electron. So helium would be a 2s2. As it's plus, it's just 2. No, it wouldn't. Helium would be a 1s2. But because it's helium plus, then it's just 1s1, which is the same as hydrogen. So it's a hydrogen-like ion, meaning its energy levels are given by this expression. The ionization energy, or the first ionization energy, and only if you only have 1 electron, is given by the difference between infinity and your highest orbital. In this case is just 1, as it only has a 1s1. So that would be minus 2.18 times 10 to the minus 18 joules. Z squared we can take out, and for helium will be 2, as it's the second element. So 2 squared. And then that'll be 1 over infinity squared minus 1 over 1 squared. And so 1 over infinity is 0, so that goes to 0. And so we get a minus 1, which is going to cancel with our negative out front, giving us 4, so that's 2 squared, times 2.18 times 10 to the minus 18 joules, which equals 8.72 times 10 to the minus 18 joules. It also wants the answer in kilojoules per mole, so that means we need some conversion factors. So a kilojoule is 1,000 joules. And to get into per mole, we just need to multiply it by Avogadro's number. So I'm going to try to make it less messy. So Avogadro's number is 6.022 times 10 to the 23. 1 over moles are the units on it. So that'll give us our kilojoules per mole. And then if we run this through our calculator, we get an ionization energy for helium plus of 5251.184 kilojoules per mole. All right, and I guess we're not really given any significant digits because everything's a constant, but I guess we're only given 3 significant digits on the Rydberg constant, so I suppose it would be 5250, but I'm just leaving everything in there. So this looks good.